Hi there, I am Ümit Alkuş. In this video, we will solve one problem in chapter 24. The below figure shows equipotential surfaces established between two charged metallic plates. How much work is required to move a proton A from point A to point B and B from A to point C? The work on a charge done by the electric force is calculated by the formula negative Q times delta V, where delta V is the potential difference between final potential and initial potential. And the work done by the applied force on Q, that is applied by U, is calculated as Q times delta V. In the problem, you are asked to find the work done by U. So we use the formula WA equals Q times delta V. In A, the proton is initially at point A, whose potential denoted by V initial is 50 volts. And the final point of the proton is B, where the potential is again 50 volts. We know that proton has a charge of positive electron charge. As a result, the work required to move a proton from point A to point B is calculated by this formula. Thus, the result is 0. This result is reasonable because there is no potential difference between point A and point B. This means that you don't have to perform any work. In B, the proton is initially at point A, where the potential is 50 volts. Finally, the proton is at point C, where the potential is 70 volts. We write these values into the formula of Q times delta V. Therefore, the result is 20 electron volts. We know that 1 electron volt is 1.60 times 10 to negative 19 joules. So, we write 20 times 1.60 times 10 to negative 19 joules. If you calculate, you obtain approximately 3.20 times 10 to negative 18 joules. As you see, the result is positive. This is logical because you must do a positive work to move the proton from a low potential to high potential. Another way of looking is the following. From the positive plate to negative plate, there is an electric field. And since the proton has a positive charge, the electric force on this charge because of this electric field is to the right. And to move the proton from point A to point C, you have to apply a force in the opposite direction to this electric field. Therefore, you must do work. Okay, we are done. Thank you for your attention. See you in the next video.